Geographic regions are able to take advantage of their unique characteristics to promote growth and reinforce their strengths as platforms for competitiveness. This discussion will reveal executive insight into engaging partners to invest in a shared infrastructure and the critical elements of innovation ecosystems that enable regions to convey global manufacturing competitiveness capacity. Please welcome to the stage Mark Johnson, Director of the Advanced Manufacturing Office at the Office of Energy Efficiency and Renewable Energy at the U.S. Department of Energy. Craig Blue, Chief Executive Officer at the Institute for Advanced Composites Manufacturing Innovation. Dean Jones, Global Director for the Electric Drives Service Group in Advanced Technology and Engineering at Deere Company. John Milton-Benoit, Senior Director for the Advanced Manufacturing and Service Technologies Program at United Technologies Research Center. Jeffrey Wilcox, Vice President for Engineering and Program Operations at Lockheed Martin Corporation. And Andy Wilson, Director for Strategic Business Development at X-FAB, Texas.
Well, thank you everybody, and welcome back. Please come on up to your seats and we can get going again. I'm going to start here. I thought it was interesting in the last section and backstage we were talking, and people were saying, oh, this part of our country is really good at innovation, and this part of our country is really good at manufacturing. I thought I'd start out with a real quick quote here from an interesting philosopher. It's in the encouragement of manufacturing is in the interest of all parts of the union. So that was written in a report to Congress on the state of manufacturing in 1791 by Alexander Hamilton. So for those of you who are here, if you go about 100 yards out that side of this building, you'll find where Alexander Hamilton's house is, actually. We're sitting on his property. He went on, it's kind of interesting looking at what they talk about. It says, not only the wealth, but the independence and security of the country appears to be materially connected to the prosperity of manufacturing. Whence it follows that it is in the interest of a community and in the view of the eventual and permanent economy of that community to encourage the growth of manufacturing. So our founding father started this conversation that we continue. I think it's really important to recognize that this is something that's essential to what the United States is. How do we do this? And it's what really been a foundation of our entire union. And I think it's an honor for all of us. We should recognize that we're carrying that torch at this time. And first of all, I want to thank you all for doing that. The purpose of this panel right now, I should say, by the way, that's what I get for having a wife who's an American historian. Is really talking a little bit about these innovation ecosystems. And we've heard about this today, and the idea that really working together we can get further in terms of public-private partnerships. We've spent a lot of time in the last couple of years trying to stand up some of these public-private partnerships, really focusing on manufacturing, how we unlock the innovation capacity we have in our universities and our national labs and in our private sector, getting them to work together so they can wind up really being successful. And we really have 5 leaders in that field here from the national labs, from the private sectors, and some of the NNMI programs as well, to share some of their experiences and some of their thoughts in that area. And we want to dig into that. Really kind of 3 things that we want to dig down into. One is the idea of having these communities of innovation and public-private partnerships with shared facilities and ecosystems. The second, and I think is really anyone that you dig into this, it gets down to, it's about people. It's getting that people-to-people and organization-to-organization interaction so they can really work together, they can wind up moving forward where there's that shared interest in driving innovation. And to be able to do that, it's incumbent on us to say, how do we break down barriers? Whether it's structural barriers to organizations working together, and whether it's just at the heart of it, speed. So that's the 3 things we kind of want to dig into in the next 45 minutes or so. I will say with the last sort of 15 minutes of this panel, what we're going to wind up doing is opening it up to the audience as well. I think we've got some people with some microphones, so we're going to open it up to some conversations with that. So I'm going to start out just on my left here with Craig. You've spent the last year standing up IACME, the Institute for Advanced Composite Manufacturing Innovation. I wonder if you could share a little bit with what you've seen in terms of the growth of that community and the build out of that ecosystem around your institute.
Okay, thanks, Mark, and thanks for having me here today. Yeah, it's been an exciting year. The approach that we took was we first reached out to industry and said, what do you really need in terms of innovation? And they wanted capability, shared infrastructure, close proximity to where they manufacture. So that's really the approach that we took. The institute that we stood up, the Composite Institute, really spun around automotive composites, wind, and compressed gas storage. So we went to where they're making automobiles today. So we put our technical focus area in Michigan at Michigan State University. Still 70% of all the R&D done in automotive area is actually still done in Michigan. And then I'm not going to walk through, but we stepped down into Ohio, which is number 2, over into Indiana, which is number 3, Tennessee's 4, and Kentucky's 5. And then we stood up the institute. We did go out to Colorado for our wind focus area, but kind of speaking to what's happened, we've had a tremendous reception. To date, we're 9 months in. We have about 130 partners signed on already as consortium members. We have about another 120 in the queue. I think another really important fact is last month we went to JEC, which is the largest composite show in the world, over in Paris. And the reception to the international community that the United States, I'll just be blunt, is finally moving and catalyzing and bringing the community together. So internationally it's being recognized. We have essentially 250 companies working close with us, a variety of universities, national labs. We're really making this a national institute. So it's been warmly received.
Great. So Dean, you've been with Deere, and Deere's been a big part of the Council on Competitiveness in this partnership. And I know you wind up participating particularly in some of the power electronics areas around the NNMI Institute at Power America. I wonder if you could share some of your experience from the private sector perspective in working with Power America.
Sure. We're very, very thrilled to be working with Power America and NC State. One of the things that has been really great is when our technology roadmaps match up with this kind of innovation and this kind of financing, because this is work that we would get done one way or another, and it's great to be able to partner up with the government. Wideband gap is absolutely the next generation in terms of our inverters. John Deere is pursuing electrification in a very, very serious way. Within our own company up in Fargo, North Dakota, of all places, that's our power electronics center of excellence. So that's where we make all of our inverters and power electronics. So it's been working very, very good. The Renewable Research Lab has really helped with thermal modeling and packaging, because that's probably one of the hardest things in power electronics is heat dissipation and packaging. So it's been working very good.
Great, great. I'm going to skip down here to Andy. So in the power electronics area, you've just opened up this foundry model out at X-FAB around silicon carbide, which is this advanced power semiconductor. And I think if you could just share with the audience here a little bit, I know we're very excited about it within the Department of Energy, but I don't think people realize what it means in a semiconductor when you jump to a foundry model, how that really unleashes manufacturing, product development, and real commercial engagement. I wonder if you could share a little bit with that.
Yeah, I think there's probably 2 different divergent trends that happen in the semiconductor space. And one trend is the cost of a manufacturing facility, a wafer fab, continues to go up and up and up as technology's advanced. I think if you were to build a state-of-the-art silicon wafer fab, you're talking an investment of several $billion. The other divergent trend is that you have small companies that create highly innovative solutions that could never support that investment. And so a foundry allows for a shared investment structure to be able to support a multitude of different innovative small startup companies and can continue to grow them and expand the capacity as they need and mature in the market. So this is a well-established model in silicon. However, it is not a model that has moved into silicon carbide. So we are a silicon foundry, so we are familiar with that model. That's the model that we engage under, but we believe that translating that to silicon carbide, which has some nuances, the model has to shift slightly, is a great opportunity to unlock a lot of potential. I think the last thing I would say is we had made a strategic decision to move in this direction back in 2013, but from a risk assessment and an investment capability or positioning, we had a pretty slow pace that we saw unlocking that or realizing that potential. And that got accelerated dramatically by the DOE investments into Power America. And I can say that without reservation that we are today at a capability that we would not have been in for another 2 or maybe even 3 years had it not been for the support of the Department of Energy. So I think it's a great example as they've moved from or look to invest into manufacturing capability. And I'm thrilled to say that we've been a great benefactor from that. So
yeah, that's great.
Thank you.
Well, I think the country's going to be a great benefactor of it. I look back by comparison to some other federal programs in the 1980s when we really did face that big uphill challenge of Japan really taking over in the silicon industry at the time and some of those issues. That there was a program called Moses that was stood up to do the exact same thing in the silicon area. And as a result of that, it unleashed the ability so companies like Cisco and Broadcom and just everyday companies that we have now are able to access and leverage the information technology in the semiconductor space without having to stand up that infrastructure themselves. And it really revolutionized that in the entire Silicon Valley. And I know from my perspective, I'll say that's my hopes for what you wind up doing here as this opens up in the power electronics area, the exact same kind of breakthrough on it. So, Jeff, if you could share with us, I know Lockheed Martin's been a great partner with the NNMI program. I think your CEO's come out and said we're going to partner with as many of these as we can. It's a great program. I wonder if you could share some of your observations on the NNMI program and some of these ecosystem efforts and how the Department of Energy is moving forward in some of those areas.
Yeah, so it's been an amazing journey, and we made a decision, as you mentioned, at the executive level about 5 years ago to invest in this ecosystem. Lockheed Martin is fundamentally a system integrator, and so the health stewardship of our supply chain, something like 30,000 suppliers, is critical to our success and our customers' success. So made that decision. We were a sponsor of the original MIT study that gave kind of the academic backbone to the link between manufacturing and innovation, the PI, the production and the innovation economy. Advocated for RAMI on the Hill, which is what turned executive action into legislative authority for the NNMIs. So I've been very active since the beginning because we really believe in it. We believe in this concept of the public-private partnership to bridge what we've been calling the valley of death and to get these technologies into the U.S. industrial commons so that we can scale them up and they are available to integrators like Lockheed Martin and other OEMs to solve problems. So it's been a great journey. It's also been fascinating. They're all a little bit different. The DOE, the DOD ones. Commerce now has solicitation out for 2. And what we've been trying to do in our role as having been kind of early and present in the first 7 as members is to help share best practices. For example, advocating for low membership fees for small companies, tiered membership fees, which most of them have. It's very important if for a few hundred or a few $1,000s, your small business can become part of this ecosystem. If the barrier to entry is too high, it's just too hard. Making sure that we were talking about kind of the regulatory aspect. When you talk to small businesses, I serve on Secretary Pritzker's Advisory Council and the MEP Advisory Board, and ask them what are the barriers to innovation. The first thing they usually say is regulation, followed by tax and workforce. Typically, it's not really technology. So the NNMIs have really served to take that burden off the small companies and contract directly with the various partners. So it's the barrier to entry gets lowered. One of the things we've been advocating for as these all grow up and mature is a little bit, it's a long time from start to finish. For us, from the day I got to go down to IACME with Craig and shake the president's hand, that was very exciting. From that day to signing a membership agreement or a contract for the center, and then the agreement is, a year and a half typically for all of them. So anything we can do to speed that up, I think would be helpful. But it's an exciting time. I really believe we're creating the building blocks, the precursors of something exceptional here in the U.S.
Great. Well, thank you. So, John, with United Technologies, again, big OEM, works well, has their own research center. What we found is we wind up running into United Technologies at a lot of places where we've got national labs, we've got universities, we've got innovation institutes, and we find that you're a great partner on that. And I wonder if you could share some of the experience, in particular, some of the things we're doing with the labs around high-performance computing and some of that area we're doing.
Yeah, absolutely. So we've been involved in a number of these institutes from the beginning. 3D printing is one of the aspects that I've been running under my program office as well. And what we find is if we really want to take advantage of additive manufactured products and processes, the certification of those products is very difficult. Lots of testing, hours and hours of testing, lots of experimental data required, gathering required. And what we need to do is have a better understanding of the physics behind it to help reduce that certification process. And so one of the things that we did is we teamed up with LLNL and Oak Ridge on high performance computing for manufacturing program, where we're looking at a key element for us in understanding the microstructure of these additive processes is really understanding the physics behind the melt dynamics behind the laser melts. Basically, a laser melts powder, it melts into a liquid and then resolidifies. And the microstructure of that solidification process has a major factor on the fatigue, performance, and life of parts. And so what we've done, the problem behind this is when you look at the physics behind it, it takes perhaps a month on a supercomputer to run a laser path of 1 inch if you're looking at all the physics. So we've developed an approach where we're able to do analysis in real time as the part is being built using some reduced order models. The question is, how do you validate these? And that's where we went to the high performance computing to help. So they have physics-based approach that really digs into the deep physics, takes a long time to run, but it can help validate our models and be able to rapidly approve this process so we can use it in certification. And I think one of the key elements behind this, you talk a lot about the shared infrastructure. And high performance computing obviously is a big factor, but it's really the people at the labs that make the difference because they have the knowledge and expertise to be able to sit beside us from a research center perspective and augment our capabilities. So we can really collaborate well in that sense, and we're really excited about those programs.
That's great. I have to share a story here that I was at a meeting about a month and a half ago at one of the labs on exactly this problem. We had a number of experts from the Air Force were there at the time, but also brought together people from the computer science people that are the programmers of those exascale computers. And either they're trying to figure out who's going to win the baseball league quantitatively, or they bring, these are algorithm development people. They don't know 3D printing from anything. But there's one guy in particular I was noted by. He literally started jumping up and down in his chair, getting excited on this 3D printing problem. He said, I'm not sure our next generation computer is going to even be powerful enough to do this. And he's like, this is like the most exciting mathematical problem that he can solve. So what this points to is that by working with manufacturers on these real problems that we're having and we're facing, it's actually pushing the state of the art of the scientists that are out there that are trying to develop that next generation technology. Probably shouldn't make a joke about them figuring out the baseball tournament, but or the World Series. But
it's bragging rights.
Yeah, it's Moneyball. But it really is a great partnership by having those things together and pulling that all together. You both talked about in terms of a little bit having the small business partners as a participant in this as OEMs. What I see is that there's a number of small businesses that are starting to show up that are part of the ecosystem of an OEM because your ability to innovate and get product out the door suddenly depends on having some of these key suppliers getting that innovation, getting that training, getting that technology down in there. And I'm wondering, I'm going to roll back to Craig here, if you could share sort of the story of Cincinnati and Techmer. I know we all look at this whole 3D printing of cars, but a company like True Design that was developing the technology in the supply chain for that is really a key partner on that.
Yeah, I think this is a real key element, particularly when you're looking at new technologies. You have to evolve the whole supply chain, particularly if you're looking at high volume, because one application could completely consume what's in the present supply chain. So to your point, as we were looking at large-scale additive manufacturing, actually we started with Lockheed Martin, we had to look to an equipment supplier, and Cincinnati Incorporated, a 115-year-old company out of Cincinnati, Ohio, of course, took their laser-based technology and we married it with an extrusion technology, and that was just one facet of it. Of course, we had to develop the materials for the process. We worked with a local company, Techmer. They're an SME. And then when we started looking at the application to a car and finishing became a real key component, then we looked to yet another local company, about 10, 15 people for all the surface finish. And yeah, we did it for the car, but ultimately the big application is the tooling industry, molds. And how are you going to do this? And this is, while they're a relatively small company, like I said, 10 to 15 employees, they've been actually making molds for years for compositing. So they played a key role. In addition, also a company out of Indiana, Thermwood, was involved in all the machining. So we had the whole supply chain involved, up to and also including an OEM in the case of local motors. And really, over the years, and I've been in this area for about 20 years, if you don't have that integrated supply chain involved, at the end of the day, who's going to really commercialize? So you have to have them as part of the process, because they're also going to have to make the business case for them to make the type of investments to move forward.
Yeah,
So
that's great. And one thing I'm going to share with folks here, and this is kind of putting myself out on the line on this. So we're in the middle of saying what are the other things we can 3D print with this, and what are things it works so well with a car doing it in public on this. We were backstage talking about this. What the team is committed to do is they're going to go to a trade show in the summer of 17 and make a hydraulic excavator, the arm for a hydraulic excavator, print that on a trade show and have that arm working with all the embedded hydraulics in it at the ConExpo in the summer of 17. So they've got a year to get there. Now I brought that up to Deere, and your comment was, wow, you could really do that? So I thought that was exactly the kind of response we want to wind up having, is if you can wind up opening up, by trying to take these things on, that becomes a real challenge out there. So you said you're also a part of a couple of the other institutes, DMDI and some of the things. I wonder if you could share some of the experiences. And I know you were talking about some of the issues of how do we speed this up? How do we wind up harmonizing things? And where some of those experiences are going forward on it.
Yeah, I think speed is probably the biggest feedback I've gotten. We're involved with digital manufacturing, so virtual logistics, augmented reality, and also there's one other area. It's evading me right now. But I think one of the challenges for that institute is speed. We're working a lot with Rolls-Royce, as well as Iowa State, and I think a frustration has been the decision making. There's so many stakeholders, it's taking so long, and we need to move. I mean, our company is about commercialization, our company is about feeding the world, our company is about keeping farmers and construction businesses making money and being profitable. So our time to market is going quicker and quicker, and our development times are being compressed. So that would probably be the biggest feedback. We need to get the support out of digital manufacturing to help us. I remember the third one was on the digital thread.
Oh, the digital thread, yeah. Because I think one of the things that's noteworthy is how much manufacturing is actually transitioning from being all about materials and processes and in the technology space to materials, process, and information. And what are those information tools to wind up speeding that up? And that's a key area where the Department of Energy can actually provide a lot of resources and roles in that area. So how do we wind up, I know, Craig, you're always trying to beat on speed.
yeah.
How do we do this better?
So no matter what agreements we have, I think a real key point, and this was brought up in a meeting I was in last week, it takes two. So you have to have push and pull on both sides. We have agreements that are done literally in a handful of weeks, and we have others that go months. So there has to be an impetus, a drive on both sides. We're continuously looking at streamlining the process. Something we've been very successful in the manufacturing demonstration facility, taking a little bit of Bill Peters' thunder, is we standardized a CRADA, and we took all the best terms for our industry partner, and we put them inside. And then we try to make it such that it's non-negotiable. At the end of the day, a lot of the holdup is, it's with the lawyers. I know I'm not supposed to say that, but it's with the lawyers, and going from desk to desk. And making it non-negotiable and giving the company the best terms really help expedite that process. We work with some traditionally difficult to work with industries, and we were doing agreements inside of 7-8 weeks. So, but we're continuously looking at streamlining the process. We're working directly with DOE and headquarters. As we were talking, there's certain terminologies or clauses in there that companies just cannot overcome. So let's go back and let's see what we can do, and then let's make that short form CRADA even stronger. let's streamline the process continuously. But again, at the end of the day, it takes both sides working hard.
I think the encouraging thing is we still have industry partners that we're all willing to bang our heads on this thing together, and it's ever growing. I know for the MDF, you'd mentioned one of the metrics that I look at is just how many unique visitors we have every week. We get a weekly report on this, and it's continually growing over the past 5 years, and that's a great sign to wind up seeing that's out there. So first of all, thank everyone for working on it. One of the lessons we had on that was working with small businesses. We have this small business voucher program that we've started, and having the exact same short form CRADA so that small businesses can get in there quickly, have some assurity about what they're doing. I think it's shown some real successes on that and getting that forward. The other issue of people, though, is getting people to work. So, Andy, I'm going to set you up here real quick because I've heard you talk about this before. As you stood up this facility, where would the people be today if we wouldn't have gone down this pathway?
Yeah, that's a pretty simple answer to a pretty simple question in that we are in the silicon world. To maybe provide a little bit of a background, that this facility was built in the late 1970s. It was upgraded through the 80s and the 90s, but since then, probably following the trend in semiconductor, most of the investments happened overseas, and so there have not been a lot of major investments into this facility. And as we look at the landscape of facilities that have the same capability as we do in the U.S., since 2000, probably 70 to 80 have closed their doors. And there's probably less than a dozen, again, of these legacy, 150 millimeter semiconductor facilities. And maybe we're just more stubborn, maybe we couldn't see the writing on the wall, but we've kind of hung on, but was very apparent we needed to reinvent ourselves to be able to stay viable moving forward. And I can say without any reservations that had it not been for the collaborations that have been promoted and offered by the NMMI program and the Department of Energy, that our ability to execute of this transition plan into silicon carbide would have been not nearly as likely to succeed, certainly would not have happened as fast. We would not have made as much progress as quickly as we had. But then even the intangibles of the collaborations that we've been able to develop with different partner companies that will become our customers, all of these are intangibles that have been, I guess they're not intangible, they're very tangible. So, things that have been brought to us by this collaboration institute. And so it's been, to me, it's been a great program.
Would it be fair to say that had this not gone forward, there's 100 or so people in West Texas that might not be walking home with paychecks?
Well, our payroll is 400.
Yeah.
So I think that you would really look at that we were in the sunset of our capabilities as a silicon fab, and those jobs would not have continued beyond a horizon of 5 to 6 years had we not made this pivot, and that pivot was fully enabled. I think one of the other things that I would say, just to put a plug on the Institute, is this is the first federally funded program that we've participated in. We're a manufacturer, and a lot of the federal funds are really geared towards the early TRL level type of developments, R&D, and that's not where we participate. So there was a little bit of trepidation of, is the overhead and the compliance requirements that would come with this, would that overweigh the benefits that we get from it? And I think that having these institutes as a kind of a moderator have benefited us in that standpoint. But I think it's also been, for me, exciting to see the shift moving from not just developing technologies and saying, well, we assume that these will be manufactured, hopefully here in the U.S. sometime, to actually extending that focus to say, okay, we've got to be participatory in the manufacturing developments as well. So that's been very encouraging for me.
Yeah, great. So we're going to open this up to questions in the audience in just a minute or so, but I want to roll it back over to United Technologies and Lockheed on this. Why don't we go with Lockheed first? So how do you see going forward the NNMI having the greatest impact in partnership with your company? You know, where are some of the areas that?
Yeah, for us, again, it's when we can come in with 2 or 3 of our suppliers and all get smart together and raise the innovation capacity of their network. To me, the most powerful thing, and frankly, the reason we made this investment in the first place was about our stewardship of the supply chain. So the most powerful element is that. I would say secondarily, and Deborah said we're here in part to celebrate Secretary Danielson's announcement about the Commerce MOU, which I think is great with MEP.
Yes.
Because MEP already has, it's 60-ish sort of public-private partnerships around the country. I think 20,000-ish small businesses and manufacturers that they reach out to. They do a lot of workforce training. So I think augmenting NNMI with the MEP network is really 1 and 1 is going to be much more than 2, so I want to celebrate that. So I would say first it's the SMEs, and second, the workforce development aspect, because there are parts of the country, the last panel talked about the abundance of talent in the country, but there are pockets where that's not really the case, and where small manufacturers in particular have a hard time getting folks that can pass a drug test and show up to work 5 days a week on time, and their growth is limited by that. So fostering effective workforce development ecosystems is another important element for us.
And just to go on the MEP partnership on this, what I'm hoping we wind up doing is, so we've got these places that have innovation, how do we make those have a broader impact across the entire United States? And I think the MEP, they're in the entire US. They've got 50 MEPs in 50 states. And so how do you find those companies? And I think a lot of the folks that are actually running these institutes and even the companies that are partners with them, you've got your day jobs. You're not out there trying to find the small businesses. So having that group that's got that connection, I think, is a real key to wind up doing that. So thank you for highlighting that. So with United Technologies going forward here, what's your hopes in working with the NNMI program?
Yeah, what I would like to see, and I think we had some allusion to that earlier, is some of the regulation around or the inconsistency from group to group. So Craig talked about how they've helped speed up process at IACME. Maybe they haven't in all the other areas as well. And from a company standpoint, we have standard work in place, we have continual process improvement. You would like to see that where those lessons learned aren't limited to one institute, but begin to get shared across all institutes so that we can make this a lot faster than it has been. So I agree, speed is a huge issue. And then I'd like to echo the comments about the supply chain. That's a key value to UTC as well. And the idea of linking one-on-one the NNMIs with the MEPs is really interesting, because at some point you have to make sure that new technology is getting into your suppliers. And maybe that wall ends at the NNMI. That helps the transition if you can get it directly down into the suppliers. And then the last point is really not just developing the technologies so that you can have advanced manufacturing components in not only your company but the suppliers, but making it easy for the worker to be able to execute those. There was some talk earlier about how do you get that capability up, these high-tech jobs. And for example, you can think about the robotics area and automation or autonomous working in the factory in combination with a factory worker. But you need to also focus on that interaction, the human-machine interaction, right? So there's a key element of technology that plays a role in adoption as well that sometimes gets overlooked. We think about the technology up front, we work it, but we don't think about what additional technologies are required to make it easy to adopt. And that's something we need to think about too.
Yeah. I think we find that, in the advanced manufacturing office, often you find, there's not a day that goes by that doesn't someone come in and say, hey, I've invented whatever the thing is, now I need to do manufacturing in it. And then you start asking them, okay, what are the other science and technology questions you have that you didn't know you had before you invented your thing, that you have to solve with these other problems before you can actually take it into manufacturing? And then that just opens up a realm of new discovery and new connections and new innovations that you need to have. So, that's exciting to see. I'm wondering, do we have any questions? People can raise their hands if you wish. We have a couple of mic runners around here. In the back here.
One issue that, Subhash Mahajan from UC Davis. One issue I'd like some answer on, the digital manufacturing is going to affect employment. What are we going to do with the reduced employment and in the future?
I'll gladly take this one on. So, Alexander Hamilton, I read that at the start of this. That was in response to what was happening in England at the time that he was asked to do that, which is just before that, James Watt had invented this lovely thing called the steam engine. And everyone was worried that, oh my God, this is going to get rid of all the people that are going to wind up having to carry coal out of mines, and where are those jobs going to go? If we've learned one thing in our 225 years of history, it is that innovation creates new jobs. It creates new opportunities. It opens up new opportunities. So the jobs you have today are not going to be the jobs you have tomorrow, but there are going to be more jobs. So you can look at a couple of studies. I think the Deloitte study highlights this as well. It's not that the US is the place that has the lowest cost in the world in terms of labor. It's that we have the highest productivity in the world in terms of labor. And that means we use technology better than anybody else. And that's a unique US strength. So what we've tried to do over the last 4 years really is to say, how do we take the universities that we have, the laboratories we have, connect them with the manufacturers to try and work on these issues around energy so we can be smarter about it, we can faster about it, we get economic growth out of it, and then there's new job and growth that comes out of that. And that's really having that laser focus on that's been what we've been about. Sorry, does anyone else want to key in on this as well?
Yeah, I'll say a couple of words regarding that. You know, the efficiency, one of the things that we see when you talk about process improvements, especially if you talk about digital thread or any real process improvement that you have to answer those questions about workforce, is really understanding the competitiveness of the corporation as well. The better that we can do, the more competitive we'll be, the more jobs we're going to create. So I agree 100%. It may not be the same jobs, but certainly there are going to be more jobs. So I don't see that as an issue myself at all.
Yeah. Great. Do we have any other over here?
Thank you. Bill Acker with the New York Battery Energy Storage Consortium. I have a question about the balance when you're creating public-private partnerships like the MMIs and others like this, in getting companies to engage substantively in the beginning, combined with the broad dissemination of information. So I'd like to learn about your experiences of the engagement of companies and particular advantages to companies getting involved in the first place early on, balanced to the mission of broadly disseminating the information, and if you give some examples to how you can optimize that.
Great. So Craig, I'm going to roll this to you.
Yeah. So kind of the advantage of being involved at the front end, you actually get to formulate what the Institute's really going to look like. This is something that Lockheed Martin has done very successfully and really kind of set the pace. So that being said, that's your launching point. Then you say, well, okay, now we bring in all these other members. What value is there? I think one of probably the best examples, if you look at a carbon fiber composite, in our particular case, about 80–90% of the entrained energy is actually in the carbon fiber. So just here recently in the last month, we had a licensing opportunity from one of our partners, Oak Ridge National Lab, for companies to come in and license a new technology, actually carbon fiber derived from textile-based PAN. What we're doing within the Institute is we're taking an internal project, we're taking that textile-grade PAN, and we're going through and taking a couple compositing technologies and then building databases, which we can disseminate to the larger group of consortium members, which will be very valuable as they assess really the utilization of this new material. So those are the type of things that we're going to be able to do in the Institute. And I see that happening again and again where we're doing more broad-based project work for the entire consortium. And then of course we have another avenue, much like the CRADA, where companies can come in, protect their IP, retain IP within a smaller group, and then move off to commercialize. So we're still learning as we go, but those are a couple examples.
Yeah, please.
Yeah, one of the things we found at Power America, when we ran it through our general counsel on the IP issues, it was very, very clean, very, very simple. What we also did, though, is you have to compartmentalize what's going to be shared, what's part of the consortium, what's not. For example, we drew a very serious box around software. That is outside the realm of doing the wideband gap. We'll stay on the semiconductor, we'll work on the application and thermal and packaging, but software was by a very thoughtful decision left out. So IP is an absolute key for these partnerships to work.
Yeah, and I think that highlights also just having transparency of the rules of the road. That creates an avenue where people can opt in, opt out, but you at least know what's going to wind up happening. I think that transparency is always an important thing.
If I can add to that, generally speaking, working with industry for 2 decades, when it comes to materials, properties, and databases, everybody wants that because you have to design. It's when you come into really the designs and models, that's where they get sensitive. So you just stay in this lane where you can share broadly, and then you exercise the appropriate agreement when you want to go over into the other space.
And I'll say for the Department of Energy, the work we've done over the past 2 years has been a lot of public engagement. So we've had a whole series of public workshops. We wound up running our entire quadrennial technology review, which was a process of identifying where are those technical areas that would have the highest impact. And particularly in manufacturing, we had an entire section looking at where those high impact areas are. And then really did a deeper dive beyond that point to say, within those technology areas, where does industry show up? Where are they willing to say, here's our goals, here's the shared targets, here's the opportunity space. And it takes a while to wind up getting to the point where you can say, hey, this is the way to go. The idea being as they roll out, though, we are having success as they wind up hitting, because we have good targets in place. We have good goals that are in place. Bill, I'm going to just also point out one thing that I'm excited about personally is how much looking at both the United Technologies and Lockheed are moving forward in the energy space themselves, in particular the whole energy storage area. I know both of them have been really stepping up as companies in the storage area on technologies that had their roots in the Department of Energy, and that's exciting to see all that wind up moving forward and hope to continue in that area. So, do we have a question?
Yes, Carolyn Chin. This is all very exciting and encouraging, but what do we need to do to ensure that we have long-term sustainable competitive advantages? It would be easy for another country that doesn't have a Congress to take a look at what we're doing and just knock us off or jump in front of us. What do we need to do?
Yeah, I think I'll start to ramble. And then someone else could dive in. This is pre-competitive research, and I know it's been a concern of everyone, is where does scale-up happen? The MIT study I referenced earlier spoke to the majority of innovation and R&D happens here, and then a lot of it scales up overseas. So it's a great question, how to protect and ensure sustainability and scale up inside the U.S. One thing we've really advocated for at all the institutes, and this is a little parochial, but is an industry-driven roadmap, so that every project has an industry sponsor. So you're not creating without somebody with a path to commercialization. Every project needs to have a path to commercialization early on. So I think that creates a bridge which at least gives us a head start as this new technology is being developed. But it's an important question that's still a work in progress.
If I can build, it's something that was spoken to earlier by Lenny at CPC. The best technology transfers people. And when you get people working together, different backgrounds, that's when innovation happens. And if you develop this ecosystem and you invite people in, we've done this a lot prior in the MDF, where companies come in and they're actually spending 3, 4, 6 months and vice versa. That's where you actually get the technology transfer. And that's very hard to replicate, and that's very hard to take away. Now, you have to be selective who you open the doors to, but I have to say it's all about the people and the people working together.
Yeah.
I can ramble a little bit too. One of the things that I see, and I guess maybe a model, at least in the power device market, of what not to do is the existing dominant power architecture, power device, is a silicon-based IGBT. That's a technology that was developed in the United States, but really it was Germany and to a great extent Japan that then took those technologies and ramped those into manufacturing. And once you get some established economies of scale, you develop then a beachhead that is very difficult for anyone to come in and then catch up and to bridge that gap. So again, I think that that's one of the things that's been so exciting about the NMMIs is to say, let's not only develop the technology here, but let's become part of priming the pump of manufacturing to establish that capability here, to establish that beachhead, and then it becomes self-sustaining. And it's very difficult for other countries to be able to bridge that gap. And again, I look at the silicon IGBT market. It's dominated in Germany, which is not a low-cost, low-regulatory nation, but have been able to stay ahead because they were able to establish that beachhead. And I think that that's a big part of what NMMI plans to do and has a goal to do here.
Yeah. And I think one last thing in regard to that is to build upon what Craig's talking about, people. It's actually people working in partnerships to wind up maintaining it. So I think a key element of this, if you look at, for instance, the Council on Competitiveness here, this is part of a 30-year partnership. And it's really important to have that sustained impact, to have that sustained continual reminder that manufacturing is important, innovation is important, competitiveness is important. And as the folks at Deloitte said earlier this morning, there's not a country in this world that isn't envious of the greatest university system in the world and the greatest national lab system in the world, and how we can wind up tapping that is really a key element of how we can wind up continuing to drive forward in that competitive environment. So, well, with that, I want to thank everybody. I think we're coming to the end of our time at this point. Thank you all for joining us.